Alright students, this is another video of mathematics, and we are about to end introduction to trigonometry chapter. We will try to solve exercise 12.3 today. Before starting with the exercises, let us look at some of the basic concepts of trigonometric. Trigonometric ratio is basically related to a right angle triangle. So we have a right angle triangle over here. This angle is a 90-degree, and we have named the sides of the triangle. The side opposite to the 90-degree angle, is called as hypotenuse. And if you consider, there are basically two angles left after the 90-degree angle, and they are an acute angles of the triangle. So if you consider one angle as theta, theta is basically a Greek letter, and it is used to represent an angle. So if you name this angle as theta, then the side opposite to the angle is called as opposite side, and the side adjacent to the angle is called as adjacent side. Okay, so we have a right angle triangle over here. We have two acute angle in the right angle triangle. We have named as theta. Then the side opposite to this angle is called as opposite side, and the side which is adjacent called as adjacent side. Okay, now remember the name of the sides and how we have considered the side with respect to the angle. Okay, one more thing, trigonometric ratios are usually used to find the unknown side of a right angle triangle, unknown side or unknown angle of a right angle triangle. And to find the unknown side and unknown angle, we use a trigonometric ratios. There are total 6 trigonometric ratios, but today we are going to see only 3 trigonometric ratios, and they are as follows. So this is another right angle triangle. We have considered this angle as taken the name of angle. This angle is angle A instead of theta. So there are the 3 trigonometric ratios which we are going to study in this video are sine, cos, and tangent, which is also called as tan. Okay, sine of A represents the angle over here. Okay, sine of angle A is opposite upon hypotenuse, the opposite side, ratio of opposite side upon the hypotenuse side. Okay, so this is something which you will have to remember. It is a kind of a formula, you can say. Sine of A is equals to opposite side upon hypotenuse side. Cos A is equals to adjacent side upon hypotenuse side, and tangent A is ratio of opposite side upon adjacent side. Okay, so these are the ratios of these 3 different trigonometric ratio. Okay, now for every angle, for different angles, there are different values of these trigonometric ratios. For sine of 0 degree is equals to a value of 0. This also you'll have to remember, you'll have to memorize this table, will be helpful for you to solve the questions further. Okay, these are the values which we have already find, and they are fixed values. Sine of 30 degree is equals to 1 upon 2. Sine of 45 degree is equals to 1 upon root 2. Sine of 60 degree is equals to root 3 upon 2. Sine of 90 degree is equals to 1. Similarly, these are the different values for cos and tan for these different angles. These are standard values, and these are standard angles, and for these respective angles, the value of the 3 trigonometric ratios are given over here in this table. This table is very useful when we are solving the questions, and how we will use this table and the previous slide, the formulas given in the previous slide will be very clear to you when we solve the first question of exercise 12.3. Exercise 12.3 is a word problem with respect to the real life and with respect to the trigonometric ratios. Okay, the question says that a man is standing at 20 meter away from a building, making an angle of 45 degree with the top of the building. Find the height of the building. Okay, this is a simple question where a man is standing at 20 meter away from the building and making an angle with the top of the building. Like when the man is looking at the top of the building, it is making an angle of 45 degree. Find the height of the building. We have to find the height of the building, and this is where the actual trigonometric ratio plays a very important role. So to understand the question in a more better way, let us see it in the form of a graphics. This is a building, and if I consider that a man is standing over here at a point C, and when it is looking at the top of the building, it is making an angle of 45 degree, and this is the distance of the man from the building, which is 20 meter. Now if you see, building is always a strand that is perpendicular to the base, so obviously we can consider that this building is at a 90-degree angle. It makes a 90-degree angle with the road. Okay, so we can consider the whole situation in the form of a right angle triangle. Okay, so I have given name to this right angle triangle. It is ABC, and this angle C is 45 degree. This is 20 meters. So this is what I am being given in the question. Now what exactly I need to find? I want to find the side AB. If I consider this as a right angle triangle, I need to find the side AB. Now whenever you get such a question, so we will see what do we really have, what information we have, and what we need to find, and accordingly we will use a trigonometric ratio. See, we have this angle and we have an adjacent side of the angle. Okay, we have an angle, we have an adjacent side of the angle, and we need to find the side opposite to the angle. Okay, we need to find the side opposite to the angle, and we have an adjacent side of the angle. So we will think of a trigonometric ratio which has ratio of opposite side and adjacent side, ratio of opposite side and adjacent side. And which trigonometric ratio is that? Let us have a look. So when we look at the formula, we can see that, see, tangent of A, tan A is equals to opposite upon adjacent, opposite side upon adjacent side. We have the adjacent side, we need to find the opposite side, we have the angle. So we should use this trigonometric ratios. And how we will use it? Let's see. First of all, we'll write the formula. Tan of 45 degrees, because this angle is 45 degrees, is opposite upon adjacent. Then tan of 45, that means, is equal to side AB upon side BC. Then we are putting the values. Tan of 45, when you look at the table, previous table, you will see that tan of 45 is equals to 1. Let us have a look at the table again. Tan of 45 degree, tan of 45 degree is equals to 1. So the value of tan 45 is equals to 1. So tan of 45 is equals to 1. Since we don't know the AB side AB, we have to find the AB. So we have written it as x, and BC is equals to 20 meters. So I have written it as 20. I can move this 20, shift the 20 over on the left hand side. So I'll get 20 multiplied by 1. So this way I'll get x as 20 meter. So this is my answer. The height of the building, AB is nothing but the height of the building. The height of the building is 20 meter. So this way we use the trigonometric ratio to solve a problem which was related to a right angle triangle. Similarly, let us have a look at the question number 2. The question number 2 is, a ladder leans against a wall of 12 meter high, making an angle of 30 degree with the ground. Find the length of the ladder. So this is a ladder, it is leaning, it is standing on the wall of 12 meter height. So this is a wall of 12 meter height, and the ladder is making an angle of 30 degree with it. Okay, so whenever you get such a question, try to imagine the situation and then draw the figure. Okay, so the ladder leans with the wall of 12 meter high. So I've done nothing, I've just read the question and try to express it in a form of a figure. So the wall is 12 meter high, the ladder is at an angle of 30 degree to it, and we can say that since the wall is always a straight line perpendicular to the base, it will make a 90 degree angle. So we have a triangle over here, triangle ABC. Okay, so AB is perpendicular to side BC. I can assume this angle is 90 degree. Okay, this angle will be 90 degree because obviously the wall is always perpendicular. So this angle will be 90 degree. We have a 30 degree angle over here. Now I will see, I have named the triangle as ABC. We will look what do we have and what we need to find. So we need to find the length of the ladder. So the length of the ladder is the side AC. Okay, side AC, the hypotenuse side. So this angle is 30 degree. We have opposite side of the angle, which is 12 meter. We have opposite side AB 12 meter, and we need to find the hypotenuse. So we need to think about the trigonometric ratio which involves opposite side and hypotenuse. Opposite side and hypotenuse. So let us have a look and find which trigonometric ratios involve opposite side and hypotenuse. So the opposite side and hypotenuse is involved in the very first trigonometric ratio, sine. Sine involves opposite upon hypotenuse. So we will use the trigonometric ratio sine. So I have written as sine of 45, opposite side is side AB, and adjacent side, hypotenuse side is side AC. Okay, according to the formula, opposite side upon hypotenuse, which is AB upon AC. Now putting on the values for sine 45 is, what is the value of sine 45? Try to recollect. So when we look at the table, the value of sine 45, sine of 45 degree is 1 upon root 2. I hope now you are able to understand how can we find the value by looking at the table. Okay, how we are using this table to find the values of the different trigonometric ratios. These are the angles and these are the trigonometric ratio. So as we have seen, the value of sine 45 is 1 upon root 2, and the side AB is 12, and since we don't know the AC, we will put it as x. Now we will try to solve this, simplify it. We can shift x over here, we can shift root 2 on the right side. This will become x is equals to 12 root 2. And now when you can use your calculator to find the value. You will have to use your calculator to find the value. 12 multiplied by root 2 will give you 16.97. And so the length of the ladder, x is nothing but, side AC is nothing but the length of the ladder, and the length of the ladder is 6.97 meters. Okay, so by using the trigonometric ratios, by using the formulas of the trigonometric ratios, we were able to solve these real life problems, and they can be used further to solve questions which will involve a 90-degree angle. In the exercises, there are various examples where instead of a building and a wall, there's a pole or there's a tree. So we will try to imagine this in the form of a graphics, and we'll try to imagine it in the form of an angle of a 90-degree and try to solve the question. Go through both the questions very thoroughly. Watch the video again to understand properly the basic of trigonometric ratios, and then try to solve the further questions. Until then, take care and Allah Hafiz.